processes in which minerals are actually formed happen most often in two different types of liquid environments. The most common is water. Well, I shouldn't say the most common. The most two common are water, where crystals form from highly concentrated ions within water, and magma. Now, magma is the molten rock that exists inside of the mantle of the Earth. All the minerals and elements inside of the magma are free to flow, and then as they cool, they align themselves in a crystalline structure. This can happen either below the surface or above the surface. When it comes above the surface, the magma turns into what we call lava. It's the exact same thing. It's just another word for the magma that's been forced out of the Earth's surface. Now, there are a few important factors in the formation of minerals. Minerals generally are formed under high temperature, high pressure. They need lots of time, and they need a large concentration of ions within the solution. Now, this is a generalization. There are some, the exact temperature, the exact pressure will vary depending on the mineral we're talking about. Glass is a very interesting property, very similar to minerals, but not quite. Glass is not quite a mineral. The difference between glass and other minerals is that glass was molten material that has cooled solid, but does so rapidly so it doesn't have time to form a crystal structure. So if you want to look at the difference between, say, a diamond and a piece of glass, just look at the crystal structure. If the diamond is, or if it has a crystal structure, it's a diamond. If it doesn't have a crystal structure, it would be a glass. Now, if we look at minerals that are formed at very high temperatures, there is a basic model that helps us identify what types of minerals are formed at these different high temperatures. This is called Bowen's reaction series, which is the sequence that silicates crystallize. At higher temperatures, the crystals that form tend to be more ferromagnetic, whereas as you get to lower temperatures, the minerals become more and more rich in silicon. Now, when you look at minerals formed at regular, normal temperatures, generally these minerals form when they come in contact with oxygen, carbon dioxide, and water, which is quite abundant at the surface. These minerals tend to be non-silicates: the carbonates, the sulfates, oxides, halides, and the sulfides. There's one exception to this following rule with the oxides, but generally the minerals that are formed at normal temperatures, these non-silicate minerals, tend to have lower hardnesses and lower specific gravities than the minerals that have been formed at higher temperatures, the silicates. Once a mineral is formed, it can actually change to a different mineral. In order to do this, it has to be the minerals have to be exposed to different environmental pressures, different temperatures, and chemical solutions can also help change the minerals into different minerals. We've actually been able to synthetically produce a lot of minerals. We've been able to synthetically produce rubies and sapphires for decades. And just recently, we've been able to synthetically create actual diamonds as well. In order to do this, basically, we follow that procedure of altering minerals under different pressures, temperatures, and chemical solutions. Generally, in order to actually alter a mineral, we need temperatures of above 150 Celsius and pressures above 2,000 times that of our normal We can also find minerals within ores. By that we mean embedded in other rocks. Generally, these minerals have economic value, such as gold and silver, copper, and so on. When we find the ore, we find the mineral embedded within the ore in what we call veins, long, thin, flat bodies of mineral within the rock. This is a leftover crystallization that comes from the magma when it's come up to the surface of the earth, so it becomes lava. And then the impurities, the extra stuff is just flushed away in hot water solutions, allowing the magma itself to crystallize and form these nice thin layers of actual minerals. There are lots of examples of these ores, gold and silver I mentioned, but there are others like pyrite and chalcopyrite and many other minerals that are found in ores. And when we have mining operations, this is generally what we're looking for, are these minerals that are embedded within rock.